right, welcome. Hopefully your day is going well and you're excited to learn some math today. We're going to be trying to be able to solve quadratic equations using the quadratic formula. So some of the things we're going to need, although this isn't all of them, we're going to need to know what a quadratic equation is. And a quadratic equation is anything that can be put into the form ax squared plus bx plus c equals 0. It doesn't have to start in this form, but we have to be able to get it there. A solution to a quadratic equation is what value of x makes this equation true. And that's what we mean when we're solving, is we're finding what values of x will make this equation true. And the quadratic formula, which is the center of our lesson today. So the quadratic formula is pretty magical. It comes directly from math, and if you've been doing some completing the square things, you can derive it. But it's fantastic. It lets you know if you have any quadratic equation, it just tells you the answers directly. So if ax squared plus bx plus c equals 0, and this is important, if it's not in this form, we need to get it into this form before we can use the quadratic formula. If we have it in this form, then the x value will equal negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. And this is, in fact, the longest formula in all of math that anybody expects you to memorize. If you go to college and you learn college math, there are more complicated formulas, but nobody expects you to memorize them. This is kind of the pinnacle, the highest level equation, the most complicated equation that anyone expects you to memorize. So let's take a minute, and if you don't already have it memorized, this is the time to do it. There are a lot of people who, I am not a singer, and the only time in any class I ever teach in math that I do any singing is for this, because there's a piece of our memory that works better if we sing along with it. And so I'm going to sing a song, and this is awkward because this is not the kind of thing that over video works as well. It works much better in a classroom setting. But we're going to take just to make a minute to work on memorizing this. So I'm going to sing a song to the tune of Pop Goes the Weasel, which goes da 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 da. And this should help this sit in your brain for years. So here goes our song. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And what you really want to be able to do is you want to be able to write this out without having anything in front of you. If you're just taking a test, you want to be able to write out this quadratic formula. And so what this looks like is, from nothing, you want to sing to yourself, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, so that you can write this out as you go. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, of course, if you already have this memorized and you used a different song, it doesn't matter. I will tell you, a majority of teachers in the country use a song of some sort or the other, and it doesn't matter which one you use. But you want to be able to write this out on your own. So we'll be practicing this over the course of today. It's difficult in PlayPosit to make you write this out. So instead, what you're going to do is, over the course of the day, answer some multiple choice, but you want to be able to try to write it out on a piece of paper on your own. And I'll give you some prompts to do that. Once you know the quadratic formula, let's see how to apply it. Here's our first example. We want to solve this equation, and we see it's a quadratic equation because we have this x squared. Now, this is not ready to be used in the quadratic formula because it's supposed to be in the form ax squared plus bx plus c equals 0, and here we see that it is not equal to 0. So step one is we're going to make it equal to 0. And the way we're going to do this is by subtracting 6 on both sides of the equation. 6 is not a like term with any of these other things, so we're going to write it out separately. And now we have it in this form of ax squared plus bx plus c equals 0. And I'm going to write out what a equals, b equals, and c equals. Once you have if you feel comfortable with this, a lot of times people will just, in their heads keep track of what a is, b is, and c is. But here, a is 2, b is 4, and c is negative 6. If there is ever not a number in front of x squared, so if it's just like x squared plus 3x, a would equal 1. If there's a missing term like ax squared minus 9, notice there's no x's here. And so a would equal 1, and b would equal 0, and c would equal -9, because there is a 1 in front of x squared. There is 1x squared. There are no x's, so the x here for bx, the b is 0, and the c is -9. So here it was fairly straightforward. And we're going to go straight into doing the quadratic formula. So this is a great time to practice to yourself. Can you write down the quadratic formula on your own? Go ahead and try to do it. And it is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. In this case, the x values, the solutions to this equation, are going to equal negative b, so negative 4 plus or minus the square root of b squared, 4 squared, minus 4 times a times c all over 2a. Some of these arithmetic steps can be skipped as you get more comfortable with it. People will combine these into one, but for now I'll just show you all of them at once. So we're going to simplify this. So 3, we use quadratic formula. And then the bulk of the work with the quadratic formula, because all of this is very quick, is simplifying. And the first thing we're going to do is we're going to simplify b squared minus 4ac, and at the same time we're going to simplify 2a. So b squared minus 4ac, the order of operations is we square the b. So I'm going to rewrite this as 4 squared is 16. Our order of operations say we square the b, and we multiply 4 times a times c here. I like to think of this as a -4. So -4 times 2 is -8. So -4 times 2 times -6. -4 times 2 is -8. -8 times -6. Negative times a negative is a positive. So this is going to be plus 48. So hopefully we see that -4 times 2 is -8. -8 times -6 is positive 48. And so we ended up with an addition here. And at the same time, we can simplify the denominator. The 2a is 2 times 2 is 4. Here we have two things adding together, and we will add them. 16 plus 48 is 64. And the next thing we're going to do is we're going to simplify the radical. The radical is the name for the square root symbol. So we're going to simplify the square root. The first thing to think of is there a number times itself that gives you 64? And the answer is yes. 64 is a square number, which means it has an exact square root. The square root of 64 is 8. So -4 plus or minus 8 divided by 4. And now this is a great time to talk about what plus or minus means. This means there are two different answers. X could equal -4 plus 8 divided by 4. That's the plus part. Or x could equal -4 minus 8 divided by 4. These are both going to be solutions to the equation. And we add before we divide here because they're both in the numerator. So -4 plus 8 is 4. 4 divided by 4 is 1. So one of the answers is x equals 1. The other answer is -4 minus 8 is -12 divided by 4, which is -3. And so the other solution is x equals -3. These are the two values for x that when we plug them into this equation, make this equation true. And we can check very quickly if we plug in 1 here, 2 times 1 squared plus 4 times 1 does give us 6. And -3 works as well when we plug it in. These are the two solutions. Now, when it comes out to whole numbers like this, it means you could have solved this in another way that didn't use the quadratic formula, like using factoring, and it probably would have been faster. If you can factor well, it usually goes faster. The cool thing about the quadratic formula is it can solve problems that cannot be solved by factoring. Let's look at our second example. Here we want to solve x squared minus 6x plus 4 equals 1. We should notice right away that it's not equal to 0. And so our first step is to make it equal to 0. So we've got x squared minus 6x plus 3 equals 0. And now we're going to jump into the quadratic formula. X equals, I guess we should say what a is. A is 1, b is -6, c is 3. So x equals -b. Negative of -6, I'll put that here, But a lot of times we'll skip this. If it's -6 and we make it the negative of -6, that will become +6 and we can skip straight to that. So x equals -b plus or minus the square root of b squared minus 4ac, make sure the root goes over the whole thing, all over 2a. Another opportunity to check yourself to see if you actually know it. We're going to simplify things to begin with. I can simplify -6, it's +6. I can do -6 squared. -6 times -6 is +36. This b squared term will always come out positive because both a negative times a negative and a positive times a positive are a positive. Here we've got -4 times 1 times -3. -4 times 1 is -4. -4 times 3 is -12. And so we have 36 minus 12. All over 2 times 1 is 2. I can simplify 6 plus or minus the square root of 36 minus 12 is 24. And unlike before, 24 is not a perfect square number. There isn't a number times itself that will give us 24. That's a whole number. And so we need to take a break and make sure we understand how to simplify square roots. So let's do that. This is how we simplify radicals. We're going to use the property that the square root of a times the square root of b is equal to the square root of a times b, and that's true for positive numbers. And so what we're going to look for is we're going to look for numbers we can actually do the square root of. There's multiple ways to simplify square roots, and my favorite, the way that I feel like is the fastest, is to make use of square numbers that we can actually do the square root of. And so the square numbers are numbers that come from squaring a number. So 1 is a square number, although we won't end up using this because it's not helpful here. 2 squared is 4, and so 4 is a square number. 3 squared is 9, so 9 is a square number. 25 is a square number. 49 is a square number. 100 is a square number because it comes from 10 squared, etc. And so what we can do is we can try to find a square number that divides into this evenly. And if it's an even number, it's a good idea to check 4. And what we're going to do is we're going to split this up into the square root of 2 different numbers that are multiplying times each other. So one of them has to be a square number. So even though 40 could be 2 times 20, that's not helpful because 2 isn't a square number and 20 isn't a square number. On the other hand, I can see that 4 goes into 40. And so the square root of 40 can be rewritten as 4 times 10, square root of 4 times square root of 10. And that's helpful because I can actually do the square root of 4. Because 4 was a square number, the square root of 4 is 2. And 2 times the square root of 10. Square root of 10 cannot be simplified because there are no square numbers that go into it. And so square root of 4 becomes 2, and 2 times the square root of 10 is the simplified form of square root of 40.